Hey, so guys, my name is Cherno. Welcome back to the series where I grab my first game that I made in Java in C++. What am I doing? Why am I doing the intro like that? All right, so welcome back to this series. Genesis is the game we're recreating. Those of you who are new here, this is what we're making. I made this in Java like 11 years ago as my first game. Run around reproducing with women, you know. It's everyone's first game, right? So what we did last time, episode will be linked up there, is basically... Why am I in that file? Basically we rendered some actual sprites. We read the sprite sheet that we had, which is this bad boy over here, desperately looking for sprites.png. Here it is. So we have these sprites. These are the original sprites. We're going to try not to modify this file at all because we're trying to kind of port it in a one-to-one kind of way. We have these sprites, and this is little player character that we decided to test out and see if we could render, and we can in fact render it. Here it is. We have some very randomly generated pixels, and then right in the middle of the screen we have this character. This character doesn't have a name. I'm assuming it's implied that it's little Cherno. Little Cherno just running around the island with all the women. That's yeah. I just don't make games like I used to. Anyway, so we have this guy, we have this character here. Let's continue on with doing whatever it is that we're doing, because, and I'm saying that because I actually don't know what we're going to do this episode. I mean, it would probably logically make sense for us to, I guess implementing that screen class is what I kind of was meaning to do. So that's what we actually set out to do, I think, in the last episode, but then we realized that instead of implementing the screen class, which is basically like the renderer, right? It's what takes all the pixels and actually writes them into like the screen buffer. We couldn't really do that until we read in some pixels to render, meaning like some sprites to render, which is why we spent the last episode creating this sprite sheet class. And I haven't actually pushed this to Git yet. I know I said I would, but I never got around to it, so I'm sorry. But I will probably do that today, or at least before this episode goes out. So yeah, let's continue and probably implement or start implementing this screen class. And let's kind of go through it very loosely, because I think I did go through it like 1 or 2 episodes ago, maybe even in the first episode. Okay, so the screen class is pretty simple. It's a class that we actually pass into every other class for some reason. So instead of just making the class kind of static and global, because obviously we only have one screen that we render, and we use this literally for, like, this contains the pixels buffer. Well, this actually contains its own pixels buffer, which is basically just like this kind of array that we have. It's a one-dimensional array, obviously, but it's kind of interpreted as a two-dimensional array, where we have obviously width and kind of height. We have all of the pixels that we have in our screen, and they're integers, right? So they're 32-bit integers, which contain a color, and it looks like they basically contain a 32-bit color. So even though we might not really have the concept of alpha, we still need to kind of render alpha. So usually we just set that channel to FF, just because the image happens to be in a 32-bit format, that's all. Or in an RGBA format, I should say. And then we have obviously, I think, our blue channel and then our green channel. And I'm writing 2 characters here. Each character is referring to 1 byte, but in hexadecimal, 2 digits represent 1 byte. That's why I'm writing it out like this. And then obviously we have the red channel as well. So this kind of is obviously our 1 byte for red, 1 byte for green, 1 byte for blue, and 1 byte in the most significant bits for our alpha channel. That is the image format. And so we just have to kind of write that class around that. So what it's supposed to do is just copy pixels into this pixels buffer. So if I had to summarize this class in like one sentence, it would be all of these functions, basically all of them apart from set offset maybe, but all of these functions effectively write integers into this pixels array. That's all they do. And then the game class will eventually copy them, again for some reason, but it will, you can see it copies from screen.pixels into its own pixels buffer, which is taken from this image, which is eventually drawn using Java's graphics. So that is the kind of explanation. Again, I don't know if anyone cares because this is Java, but you know, it's my video. I'm just going to make it the way I want to make it. Feeling unnecessarily feisty today. All right, anyway. So, yeah, and then we have this clear function which also writes pixels 0. So let's start kind of implementing that. Now, of course, we don't have to port this game one-to-one, and I'm not going to do that. That's a bit silly for a number of reasons. First of all, because I've learned a lot, hopefully, since all the way back then, but also because there's just like some of the things that I've done, there's just no point in doing it that way. So let's make namespace Genesis class screen. So I think what I'm going to do for one is I'm actually probably not going to call it screen. I'm just going to call it renderer. The reason being, I just don't see the need to call it screen. Again, I'm pretty sure I called it screen because Notch called his class screen. And at that point, I had no idea what I was doing, so I was like, I guess that's what people do. You know, just typical child things, because I believe I was 17 when I made this, so technically a child. So we have to think about how we want this renderer to work, because what actually happened in the Java version, funnily enough, so remember, screen is basically renderer, and there is no class called renderer. Like, that does not exist. So the way that the screen class worked, as you can see, is level.render was used inside this render function. That basically went through and drew every tile and every like other sprite. So trees were like drawn on top, or parts of them were anyway. And also like torches were drawn on top, and obviously the characters, like the male and the female sprites, they were drawn on top of those tiles. But basically level.render was responsible for all of that, and you can see it actually takes in screen, the renderer, as a parameter. And if we look at that, when it wants to draw a tile, it again takes screen in as a parameter. Now we can think about like whether or not this is required, because at the end of the day, if we actually look at game, it's funny, back then, like, I made a lot of stuff static, as you can see, like a lot of stuff static and public, because I did not really know anything about, and remember, I had taught myself programming. Like the first time in my entire life where someone actually taught me like programming was in university when I was like 18. So like the year after this, basically. In high school, like I didn't learn any programming at all. So this was all kind of self-taught stuff. So of course, like to me, I was just like, I need access to this data in this other thing. I had no idea about design principles or anything like that. So for me, it was just like, make this stuff static. But funnily enough, screen would have actually been something that I think realistically should have probably been static, and not just the instance of it. I mean, you could make the instance of it static, but like the way the class was structured in itself probably should be static, because as you can see, the instance of screen really just gets created in this file, this horrific find and replace feature. Like, why are you like this? And then in the constructor of game, you can see that it calls like screen equals new screen, it calls a constructor, it instantiates that object, and that's it. So it is kind of, you know, when you make the instance of the game, which is this class, and you only do that once in the main function, you also make an instance of screen, and you never like recreate, you never do anything with it. So the whole class really is just completely static, right? And then you can see sprite sheet is another good example of that, right? It doesn't even get assigned to an object. It's just like new sprite sheet. The reason being that sprite sheet class itself has public static stuff, so that's how we access it. So this didn't even really need a constructor. You could have just made like, you know, these, you know, could have made a static function called load sheet, and you don't need this constructor in the first place. You can just, you know, call sprite sheet dot load sheet or whatever, and then pass in that thing, and you'd be done. So there are some interesting kind of design, I guess, decisions here. But anyway, my point here is just that when we think about this screen class, and we think about whether or not we actually need to make an instance of it, and then we pass it into literally everywhere, that begs the question of, can we just make it like a global kind of object, or a static object? Now, in general, I like to avoid doing that, and I'll explain why. It's because there can be, like realistically, in lots of projects that end up being bigger. So if you're working on something like a game engine, there will always be, well, not all, I can't guarantee this obviously, but in my experience, it's very, very likely that you will then realize, actually, there is a pretty good use case for having two of these. So like a really good example is like in Hazel, we basically have two kind of renderer classes. Well, we have more than that, but we have something called a renderer 2D, and we have something called a scene renderer. And we also have like a renderer, which is mostly just API commands. But anyway, scene renderer is responsible for basically taking in a scene and producing an image out of it. So it's kind of the high level thing that actually organizes all the render passes and does all the rendering. Now, you would think that maybe having one of them would be enough. And certainly for a game, it might be. But then what you can do is you can think of different scenarios in which maybe you want more than one. And so a really good use case that we have is, what if you have multiple viewports? So you need to render the scene from different perspectives. Now, traditionally, the scene renderer is supposed to only create one image, right? So it takes in a scene, it produces an image, one image. You could extend it to support multiple images, but then you need to think about multiple camera perspectives. But it's a viewport in an editor, so maybe it also has different graphic settings. Like maybe you want this to be wireframe, maybe you want that to not be wireframe. What about if you're playing like a multiplayer game and you have split screen? So you also need to render the scene. Again, usually it's the same scene, but it's in different perspectives. What if your level editor supports opening multiple scenes at once and then docking them to different tabs so that you can kind of see two scenes side by side? We need more than one scene renderer, clearly. So if we make that whole thing static, that sucks. Additionally, because of the way that Vulkan works, we can also take advantage of running those scene renderers in completely different CPU threads, because we can build up those Vulkan command buffers on separate threads and then eventually kind of come together to submit them to the GPU. So we kind of wind up with these scenarios where if we design everything in kind of a static way, like in a global way, and we only enforce the kind of you're only allowed one instance of this, then that can be really limiting in the future. Now, does that apply to us here? And that's probably the biggest question we can answer. Too static or not too static is really the question, and possibly the title of this video. If we had, like, this is a very simple game, and perhaps if we maybe decided along the way that we want to add co-op multiplayer to this, then perhaps in that scenario, you would probably want more than one instance. But I think that for the most part, we probably only want one. And in fact, the difference here is that even if we did only have one instance of this renderer, like, because the renderer is just copying pixels onto the screen, like we could easily just kind of write that kind of, you know, make that split screen, make that division, like if we had like a, you know, one of these divisions or one of these divisions or whatever, we could easily divide the screen into two and kind of do that at a higher level than the renderer. So the renderer just knows about the one image, right? So we have one image, and because we're rendering all the pixels, we could just kind of render to half the viewport, basically. So we can divide the viewport in half and just be like, okay, we'll actually render to half of this. The only possible thing that we might need to do, and which would actually be difficult to do without modifying the render class, would be like what happens if a sprite is, you know, half off the viewport, right? So if the viewport divider is this green line, and we have a sprite that really would look, you know, like that, but it's kind of, this part obviously needs to basically get clipped off. You know, can we set like a scissor region or something to do that? And that would probably involve the renderer. Anyway, we're getting way deep into this. That's just what I have a habit of doing sometimes, so I'm sorry if you don't enjoy that. But let's just start implementing it. And again, to be completely honest, I think I am going to make it static in this case, just because, like, at the end of the day, we are going to have a global image, and if we make it static, it's just going to be way easier to access. Now, you can also go halfway between static and not static, right? So, for example, what I mean by that is if we go back to, what's this, Genesis app, we have one image here, and we have, what we could do is we could basically create, you know, one renderer as well, and that renderer could be like our, you know, primary image renderer, because it targets that specific image. Renderer. Did I rename it to renderer? I did. So this kind of renderer, right, might target that primary image, but then if we have another image, you know, we could make another kind of secondary image renderer that targeted that image. Now, you also really have to think about, I guess, the object-oriented nature of this. Like, why are we fundamentally creating two different instances of the renderer class? What does that even mean? We're getting kind of almost existential crisis kind of here. Basically, what I'm saying is that the reason why these are instances in general, and we're going to provide, obviously, a bunch of functions here, such as, you know, draw sprite. And perhaps that's going to take in, you know, some parameters, obviously, and it's going to draw the sprite. Now, if we provide a function like this, and then we end up being able to call stuff like primary image renderer draw sprite versus secondary image renderer draw sprite, why are these part of a class, right? Like, why not just make these global functions that don't belong to a class? Well, the reason why we add this kind of class, not overhead, but like abstraction, I guess, on top of the raw functions, is to provide context. So we're not doing anything fancy here, like, there's no like polymorphic types here. It has nothing to do with, like, you know, different implementations of certain classes which might differ in behavior. It's more so just you're providing context. And the context itself is basically the image you're rendering to. So your draw target, your render target, that becomes the context that we provide with this actual class. So it's almost like, if you think about it this way, it's almost like we're providing a function to the image class. And then we're able to be like, hey, image, draw sprite. Versus like my second image, which doesn't exist, but my second image, draw sprite on that image. But we're doing that without really modifying this image class, because that's very like, that has nothing to do with our rendering. We don't want to couple that together because it's just an image, right? It shouldn't have a function like draw sprite. That's very specific. But in a way, we're kind of creating a class which then contains the image. And that way, it's almost like we're creating an abstraction that lets us draw sprite on a specific image, because a renderer is going to kind of hold and own a specific image that is its render target, if that makes sense. Now, of course, it can own much more context than that as well. So you might have certain render settings, you might have screen regions, as I mentioned, if you have viewports. So for example, we could make this primary image renderer only take up kind of this space and be like, that's your allowable render space, which means stuff outside that would get clipped, versus, you know, this secondary image renderer, which would only be allowed to render here. So there can be much more kind of I guess context that can go on top of that, although I guess in this case your images would be half size anyway, but still, like, you could create like certain clipping regions, do whatever you want, render settings, maybe you want certain graphics turned on here, certain effects turned off there, I don't know. They might have, you might even kind of build in like a camera into this actual renderer so that you can define like where the camera kind of is. So where is this renderer rendering from? Where's the primary kind of viewport or viewpoint, I guess, like the camera, where is it? Because that's obviously where you're rendering from. That could be part of that context as well, so that you can just call draw sprite and you don't have to be like, yeah, but where's the camera? Like, is this sprite even on the screen, or should it be like offset off somewhere? So there's a lot of like, there's really a lot of discussion we can employ here. And then, you know, what you can do though, in this case, if we wanted to avoid kind of sending this image renderer into every single like class that needed to use it. So if we had a level class eventually, yeah, and then we wanted to do like render, and then we had to obviously pass in then the primary image renderer to that. Like if we wanted to avoid doing what we did in Java, which is again passing screen everywhere, you know, into level render, then later into tile render, we could still make it kind of static at this application level. So that's something that sometimes people don't realize, I guess. They think that the class itself has to fully be static, but then what you're doing here is you're saying, by writing code like this, you're saying that there's only going to be one instance of basically this like entire class, and that's it. And that's obviously very limiting, because you might want to create multiple instances with different render targets, as I mentioned. And so what you can do instead is you can leave this not static, but then you can make this static, right? And so now it's like you, like these things are kind of like, it's almost like you're making an instance of renderer that is going to be shared across every instance of Genesis app, of game layer. Genesis app is the CPP file we're in, but of game layer, right? And then, so in a way, also what we're doing is it's like we're making game layer static. We're saying that there's only going to be one instance of game layer, because even though game layer is allowed to have separate instances of these guys because they're not static within game layer, we're saying that we're not really going to have more than one game layer, therefore you can make this static because it's okay to kind of have these be shared across instances. And then another solution would be to make game layer static. Now game layer again is created normally here and it's used here, but what we can really easily do is we could kind of make it into a singleton. So what I can do is, and again, we still kind of want the instance to be created, because you can see that what happens is the layer gets pushed here, and then the owner of the layer is going to be application. We push it into game layer, and then what that does, you can see, is it makes shared, and it puts it into the layer stack. So the layer stack is the data structure that actually owns like the shared pointer to this actual layer. But still, what you could do if you wanted to is you could absolutely make, well, first of all, we could use it as a shared pointer, you could use it as a raw pointer, you could make it as a weak pointer if you wanted to. The possibilities are endless. Shared pointer is just going to keep the object alive, which again is probably not what you want, but what we could do is we could get the game layer, Or actually, let's do it. Maybe let's do it this way. We could make it, and I think this is probably the solution I'll go with, but you can see there's so many moving parts here, so many possibilities, and I'm being extremely verbose here, but I'm trying to, actually that reminds me of a comment that I read on the last episode. Let me just see if I can find that. Aha, Nick said, honestly, it's a bit too verbose for me. I would prefer to see more coding and less explanations at this point. That's the whole point of Cherno. Well, thank you, Awesome Turtle. But like in all seriousness, like again, this series is made for kind of beginners, so I'm trying to communicate what's going on in my brain because that's kind of the point of this series. And then the fact that we're doing this to Genesis and we're porting Genesis into C++, that's just like the medium of the education and the knowledge transfer, hopefully. Because of course it could be anything, but I've just chosen this because why not? Anyway, so what we're doing here is we're actually making a static weak pointer to game layer, which we'll call, game layer instance. And you can see I've kind of made it global in a way. It's static and it's outside of the class. So it's not static as in, static inside a class, which means that it's kind of shared across all instances of that class. What it means is that it's kind of internal to this file. So you can't access game layer instance outside of this file directly. Now here's what we're going to do. Inside game layer somewhere as a function, we're just going to write a function that's going to return a game layer pointer called get instance, or you could call it just get as well. And then what that's going to do is that's going to be static. That's going to basically return game layer instance. But the reason why I didn't make this a raw pointer, which I could have, and to be completely honest, like you can do that. In fact, in this case, it probably worked, but I'm trying to demonstrate something, so I've made it a weak pointer, which again isn't bad. But what we have to do is we basically have to check the validity of that first. So there's two functions here, expired or lock. Now expired will just return a boolean, really easy for you to check to see if it's still alive. Lock, however, the cool thing about lock is that it will actually return a shared pointer of what you want. So we could have a shared pointer of game layer called like our instance or whatever, and then we can just return, like if we wanted either a raw pointer, we could do instance.get, and then we'd get a raw pointer, which could be null. Or what we could do is also change the return type to specifically be a shared pointer, and then we would return this. Now, why on earth would you do it this way instead of just having a raw pointer? The only real benefit here is that if the object gets destroyed, we specifically get null here. So the whole idea of this is that basically it allows us to check whether or not game layer instance has actually been destroyed. So has the app been destroyed, and has it destroyed kind of the game layer instance along with it? Because basically what this lock function does in a way is, I guess it just checks to see if the object has expired or not. And if it's expired, it gives us back null. Otherwise, it gives us back a shared pointer of the object. Now, why a shared pointer of the object? Because now it will be kept alive by whoever uses it. So the kind of scenario here is very simple in a way. It just means that if we call get, if the sequence is, and remember this can be multi-threaded, if the sequence is we call get, that calls this lock function, which creates a shared pointer and returns it to us. And now we might be using it somewhere, and application might decide, you know what, it's time to delete it. So when it does that, when this application goes out of scope and our game layer goes out of scope, since we've obtained a new shared pointer to that object, we actually still keep this object alive, and only when we're done and we release it, will the reference count go back to 0 and it will be completely destroyed. So that's just like an extra safety layer. And obviously if you return this and it's null, because this is just like a blank shared pointer is what you'll get back here, and we could obviously simplify this to that, then that's totally fine. We can just kind of, like the callee can just make sure that the app that you've gotten actually contains like a valid pointer if it needs to. And so this is just a way to kind of not prevent it from dying, as you can see, because if we made this a shared pointer, right? If I just make this a shared pointer, and then we just return this, what does that mean? That means I have a global shared pointer instance here. So game layer instance will never die unless I explicitly reset it. And then if no one else has the instance, it will die, right? So that's bad because I don't want to keep it alive, because that's the application class's responsibility, right? So instead what I do is I make it a weak pointer. so that it's like it just has a reference to it, but it's a non-owning reference. It won't stop it from dying. And then I can just see if it's still alive. Because again, if it's not, it will just return null. So I think one last thing I'll do to just give some extra clarity to those who need it is I'll basically write it out this way. If expired, then basically this will just return null. Otherwise, it will return lock, which again, I think that's all we can really call, isn't it? We can't get the raw pointer out of this. No, so lock is kind of, that's effectively what's going on here. We're returning null if that has in fact died. Otherwise, we're returning like a shared pointer instance of that. And then what can you do with this? Well, if you're in another class, such as, again, bad example because we don't really have many classes, but let's just say it's sprite sheet, then what we can do is we could just be like, hey, game layer, I want to get your instance, and then we can do a couple of things. Let me just include this. Again, this is very temporary. I'll get rid of this, and it's actually called genesisapp.h. Oh, we don't even have a header for this. I just realized. Oh, wonderful. So we're going to have to move that out into a header file. That's funny. But let's just say we were trying to render something and we're in here and this isn't in the game layer, then we can basically just be like, hey, game layer get, and there's two ways we could go around this. We could basically either then check to see if that instance is alive by using that shared pointer, and then we can, you know, do anything we want with game, such as access like the primary image renderer or the secondary image renderer, right? We'd need functions for that, or we need to make it public, of course, but then we can kind of, you know, we're actually in the game class here, so we can just kind of access that, and that's all good. Or we can even do a little shortcut if we know that it's going to be alive, or we're fine with crashing if it's not. We can just kind of do that and get access to that. And so you can see that in a way, and then call draw sprite. So you can see in a way, it's like we've made it global. We have, because we can just go through game layer get and then that, and then which specific renderer do we want to access. So that gives us the kind of necessary tools, I guess, to perform that task. However, you can see we can still have two image renderers. So that's still superior to just making this static. Now, are you ever going to have two game layers? See, this is where, again, it's going to get complicated, because you could go infinitely deep here. Maybe you have two running instances of your application that you kind of want to obviously be in the one instance, so therefore you do want to be able to create multiple instances of game layer. This conversation could go on forever, but hopefully the kind of insight I've given you here today can help you if you were like me and you were just constantly making everything static because you had no idea how to make two different classes or two different files communicate between them. What I've done here is I've shown you like a robust way to kind of make game layer a singleton to make it globally accessible, but that is probably a reasonable assumption to make because that's like your primary application layer. You're really only going to have one instance of that. And I've shown you how to do that in kind of a safe way where it's not going to possibly like either keep the object alive literally forever or potentially result in a crash, because you can always check the validity of that object. And also when you do start using the object, it won't die since you're kind of returning a shared pointer. Now, obviously this won't work at the moment because we're not actually setting sGameLayer instance to anything at all. So what we need to do is when GameLayer gets created over here, we call void push layer. Now at the moment we're using this function, which will internally make that shared pointer, and then it will actually return nothing to us. What we want to do is we want to make it ourselves and then use this push layer function to place it back here, at which point it will do the same thing and call on attach, and that's fine. So the only difference here is that if we come down here, we'll have to basically write shared pointer game layer, and we'll call this game layer. Or in fact, what we could do really, we don't even need that. We could just do, oh no, that's a weak pointer, never mind. So we'll make the shared pointer down here, game layer, we'll say equals std make shared game layer. So we make it like that, and then we just do push layer without the template arguments game layer. And what that lets us do is obviously retain this shared pointer so that we can then make a weak pointer out of it by just kind of assigning it to game layer instance like so. Now, the reason that's not working is because we actually made this game layer instance above this game layer class. So it actually doesn't know what type that is because we haven't declared the type until down here. Now, there's a few different ways you can fix that. Basically, we kind of need to make sure that this is, I guess, declared a bit lower, perhaps like over here. However, what that means is that we can't really call this get function. So what we can do, eventually we'll move game layer to be in its own file. I just don't want to do that today. So I'll show you another way of doing this. We could just basically take the definition of this function, which is the thing that uses game layer instance, and actually push it to be below that. So the declaration still stays up here, but you can see it's just we haven't defined the function. And then down here, we'll take this, we'll add the game layer kind of class scope to that, so that that's obviously referring to that, because you can see that's outside of the class. The class ends here, right? This is the whole game layer class. If I collapse it, you can see it's contained here. This is outside of it, but it implements a function. It provides a function definition for that specific function in that class. And then that's obviously used down here, and we can still do that. So if we do Control F7, that should build successfully. And then if we wanted to, of course, we could now kind of just call get like I am over here, and that should in fact work. Now, whilst editing, one thing that I noticed that I completely forgot to point out is why would we not just make primary image renderer and secondary image renderer static? Like, we could do this. And I did briefly show that, but I didn't really explain why I chose not to do that and why I've kind of essentially made game layer static, or made it a singleton, by keeping this kind of game layer instance as like a global weak pointer. Because if we do make this static like this, what that means is that we technically don't need game layer get at all. We can just immediately address these image renderers through game layer like that. Now, this is of course like a completely viable option. You could do it this way as well, but really the only consideration here is the lifetime of these renderers. And that's really why I chose not to do that. Because what happens is if you declare a static variable in a class, when does that die? Certainly not with the class, because it's not part of the class, it's static. So what happens is that unless you explicitly say in the destructor, which we don't even have at this point, but if we had a destructor for game layer and we reset that specific weak pointer, or sorry, shared pointer, right? Because these are shared pointers. So if we specifically reset them and nothing else is holding that reference, then sure, like it will delete it. And basically what that means is that the destructor of renderer will get called and that object will kind of be freed from memory. If you do not do that though, explicitly, because this is static, it just kind of exists. It exists forever, just like this. But the difference is that this is a weak pointer. So it's not actually keeping it alive if something else deletes it. If all the references are released from that shared pointer, it's dead. So hopefully that kind of shows you why I would prefer not to make them static like this, but just make game layer static, because that kind of gives us access to all of these variables globally, as long as we of course provide public ways of accessing them. However, it does not like screw with the lifetime of them at all, because they're still kind of member variables and they're still tied to the existence of game layer, which again, we're not taking over because we're making it global, because it's a weak pointer. All right, bit of an episode today where we basically wrote no code, but hopefully this was some good discussion regarding like too static or not too static. Didn't expect it to turn into this, but that's the beauty of this series. It's just like whatever happens, happens. And that's just the way it's gonna be. Thank you guys for watching. Oh, my hair just went up. Thank you guys for watching. Hope you enjoyed the video. Don't forget to hit the like button if you did, and I will see you next time. Goodbye.